If you haven't done so yet, make sure that you pause the video and try to answer the question on your own first before listening on. There's a key concept present in this question, and it's worthwhile to review that concept before trying to solve this question. Let's say that we bring two identical spheres so close together that they touch each other. So this would be sphere 1 and this would be sphere 2. They're supposed to be identical. This one doesn't look like it is, but so be it. And when we touch them together and then separate them, and we wish to determine the charge on each sphere, it's a rather simple matter. What we do to get the charge on each sphere is we take the original amount of charge and add them together, so Q1 plus Q2, and then simply divide that by 2. That expression would give us the amount of charge present on sphere 1 as well as the amount of charge present on sphere 2. So we want to bear this concept in mind as we work our way through this question. So in the first phase of this question, we are going to bring sphere W and sphere A together, and we're then going to separate them. Now, the initial charge on sphere W was stated in the question to be 0, and then the initial charge on sphere A is unknown to us, and that is indeed what we're trying to figure out. So what we do when we separate the two spheres and we wish to determine the amount of charge on each one is we follow the idea from before. So for example, on sphere W, the amount of charge present is going to be the original charge on W, which was 0, plus the original charge on sphere A, which we don't know, we can leave that as QA, divided by 2. Now, of course, this can simplify since 0 plus QA is just QA. So on sphere W, as well as on sphere A, we have QA divided by 2. Next, we're going to touch spheres W and B together. We already noted the charge currently on sphere W, and then the charge originally on sphere B is stated in the question to be negative 32e. So then we separate the two spheres, and we're going to come up with an expression for the amount of charge present on QW. And again, we simply sum the original charges before they were touched, and then divide by 2. Notice in the numerator we had added a negative, which amounts to a subtraction. Now we have a complex fraction here, and we can simplify this complex fraction if we multiply every term by 2. And the reason that that works nicely is because the 2 in the numerator right here and the 2 in the denominator right there would cancel each other out. So that's going to leave us with QA minus 64e in the numerator, all divided by 4. So this is the charge currently on sphere W. Finally, we touch spheres W and C together. We then separate them, and we're going to come up with the final expression for the amount of charge on sphere W. We'll come over here and do so. So we'll sum the original charges. We've got the QA minus 64e all divided by 4, plus the original charge on sphere C, which was stated to be positive 48e. And then we divide this by 2. We have another complex fraction, so let's multiply each term by 4. The 4's here will cancel. And so in the numerator, we're going to have QA minus 64e plus, this will amount to 192e. And then in the denominator, we're going to have an 8. Now, if we look carefully in the numerator, we have like terms. We have the negative 64e plus the 192e, so we can combine those. And when we do so, we get plus 128e. So this is the final expression for the amount of charge present on QW after all of the phases of this question have been run through. Now the question notes that the final charge on sphere W is plus 18e. So that means we can take this expression for the charge on sphere W and set it equal to plus 18e. And now our goal is to solve for QA. And one way to do that would be to put a 1 underneath the 18e, and then since we have a fraction on the left side of an equation and a fraction on the right side of the equation, we can cross multiply. So we'll multiply those two values. Notice that QA plus 128e times 1 will simply remain QA plus 128e. And then the final step to solving for QA would be to subtract the 128e from both sides of the equation. And when we do that, we can see that QA is going to equal 16e. Notice it's positive 16e. So this would be the final answer for the amount of charge on sphere A. Thanks for taking the time to watch the video. If you liked it, please subscribe to the channel so you could stay tuned for similar videos. And remember that you can send in your own question in the form of a picture or text to the email address shown on the screen, and I'll do my best to answer it on YouTube.